Okay, so yeah, good evening, everyone.
Good evening, sir.
Okay, so this session is basically to just revise some important topics. What are the important topics for the OPP exam? Definitely, we cannot discuss everything from week 1 to week 9 in a one session regarding the all programming problems, but we can discuss some important topics where you should focus more. Okay, and how to solve the problem, what type of problems may be asked on that topics. So that things we can discuss in this today's session. Okay, because this type of exam definitely one day preparation maybe not work. What you have done till now from the starting, how you have solved all the programming assignments, that will actually helpful for this type of programming exam. But still we have already mentioned you some very focus area, like on the discourse I have posted, which area you need to focus more, because I also know that you have lots of algorithms till now, till week 9. You cannot remember the code definitely, but some conceptual understanding you should know. Okay, so do not try to just learn the code, okay, for this type of exam, otherwise you cannot recall the code during the exam. So just remember the concept of the algorithms, and I have also mentioned some specific topics, so focus on that topics, okay, right now. So again I'll discuss all the topics today again, and what are the problems may be asked on that we will cover. And Friday session we will cover all the solution of mock problems. Okay, so meanwhile if you have any question you can also ask. uh, okay, so let me share my screen and we will discuss the topics. Mock we have also released, so you can also see the pattern of the questions in the mock. That mock question is also a higher difficult level questions, okay, because that is taken from the PYQ of the initial terms, where when actually the OPP level was the higher than compared to the current time. So that questions are more difficult or more logical. Okay, so now right now the questions will be easy compared to this mock papers. Okay, but try to solve all the mock papers by your own, and we will discuss that solution in Friday session also. Yeah, Rayan Mirza, you have raised the hand. Hello, you are not audible, Rayan. No, no, you are not audible. Some noise is coming, but your voice is not coming. Okay, so okay, let's start. So we will discuss the topics. What are the important topics? So as I mentioned, uh, there will be four questions. Okay, there will be four questions in the 2 hours duration, and the weight is again someone raised the hand. Okay, sir, in the mock question 5 dash is pre-implemented. Will it be will it? So I think I have also mentioned this type of reply on the discourse also. This is totally depends on the question. Okay, so in this mock question, actually, apart from the digestion algorithm, some additional task is there. Okay, so where you need to focus the logic after using the digestion algorithm, but still you have to focus some more logic. But if problem is straightforward on the algorithm, then in that case you have to write the algorithm, not algorithm will be given to you. Okay, so that is depends on the problem, how much task is required to write a solution. So that is depends on that. Okay, so here some additional task is there using the digestion algorithm. Then because of that we have given this. So some algorithm you will see some maybe prefix or suffix code like implementation of queue or implementation of stacks. This type of information will be given to help you, so you can directly use that. Okay, but if problem this graph problem is based on directly on the algorithm. Suppose the question is directly asking the sort like minimum spanning tree information. So in that case, we cannot give the algorithm because that is the main algorithm to solve. So you have to write. Okay, so that is totally depends on the problem statement. Okay, so Yes, we need to calculate circular path. Yeah, okay, yeah, I got it. Okay, so let me discuss one by one. Where is not bad. So the first problem actually in the OPP exam, total four problems are there. Okay, so for two, three, and four, each problem will be have the same equal weightage. Okay, 25 marks. Okay, and most of the time, first problem we ask for the linked list concept. Okay, linked list. So this is definitely you can practice on the linked list operations. Okay, problem I cannot disclose here. So because there are lots of problem may be asked. If any first thing, if linked list problems are there, you should understand that what type of linked list structure is there. Okay, so that is also mentioned in the question statement. So linked list means suppose if head pointer is given, and then structure is like this. Each node is connected to other nodes. Okay, like this is the structure. So if just see what type of structure is there in the linked list question. Only head pointer is available, maybe some question some tail pointer is also given, so that will also help you to solve perform some operation in the direct way. But just understand the structure first, and also you know that in the linked list some connectivity is there. So this question is actually generally is easy, but it also creates a problem. Many of the students actually do not connect all the links properly. At that time they got the error like something went wrong or not able to run, this type of error. That why that happen actually, because suppose if you are deleting some node. Okay, suppose this is the last node. Okay, and that contain the null. Okay, none in the python. Okay, so this information, that is the identification that this is the last node of the linked list. And suppose our task is to delete last node. Okay, delete last node. And what will happen, you are deleting the node, but you are not updating this none value here. Okay, or maybe you have just updated this value, some garbage value or something. So what will happen, and at that time our prefix or suffix code will traverse this list again to check last node is deleted or not. So at that time that code will actually check where is the null available, and that null will not be available in your list because you have not set it correctly. So at that time that code will run and will not stop. Continuously it will run, and it will check the state, and or it will actually stuck actually at that point, because that while loop which you are running to just reach the last node to this, that while loop will continuously run, or it will stuck. So at that time may some error may comes like something went wrong or not able to run, this type of error. And at that time students directly point contact to the proctor that something some issue is in the portal. But that is the actually solution issue, not the portal issue. Okay, portal issue comes with the everyone, not with a single or some single students or some time like this. Okay, so if you are getting this type of error, something went wrong. So for linked list question, definitely look your connectivity is proper after performing the operation or not. Okay. So this structure is given where the each node contain the address of next node, last node contain the null none value in the next field, header node connect to the first node. So after performing operation, any type of operation, like if you are deleting the last node, if you are deleting the first node, or if you are deleting the like third or two second any given node, after performing this operation, your connectivity should remain as given according to the structure. Okay. Suppose if you are removing this, so here null should be saved. Okay. If you are deleting this node, so this node should be connected to this. So do not escape any part in this type of question. Linked list question is very actually sometimes easy also, but if you miss any specific point, then you will get in trouble actually, and that at that time. So question to solve this type of linked list question, what you should know how to insert the new node into the list. Okay, so what are the operation actually you should know? Insert operation, and that operation should be performed on either first place of the linked list, at the last or at the given kth position, like okay, kth position. So like three place you can practice to insert the element in the exam. One linked list will be given to you. Okay, one linked list will be given to you that is already created. Some head pointer will be given to you. Okay, so that is just a, you can traverse the list. So you should know how to insert the new node, and new node class will also be given to you, and based on that class you can create a new node and add at the correct position, these three position. Same delete from the same three position, first, last, and kth position. Okay, so these are the another operation. And traverse operation is very must. Traverse means you can traverse from first to last, so just traverse all the nodes. Okay, how to traverse or how to print, how to access the nodes. So these operations are required to solve any type of problem. Okay, so solve any type of problem may be directly based on these operations. Just remove the last element, just remove the first element, just insert a one new node, or insert at the first position, last position, or maybe something else like just sort the linked list. Okay, because in week 2 you have learned lots of sorting algorithms. Okay, so these four sorting algorithms you have seen, but Python provide directly sort actually method, where you can apply l dot sort. Okay, so generally we will not ask like this, you are given a list, sort this list by a quick sort. So how we can ensure that you are using quick sort or not, you can directly apply this. But yeah, we can give the linked list. Okay, and we can ask sort this linked list. Okay, because linked list is a user defined data structure where you have created like this way, and you cannot directly apply this sort method on that. Where you have at that structure you have to apply some method. Okay, maybe you can use any algorithm on that. Like I think the best one is selection sort you can apply. Okay, so simple, traverse the list, find the minimum element, just like traverse the list, find the minimum element, read the value, and just swap the value from first position, first element to last element, so that minimum element. Just then move to the second element, do the same process, find the minimum element, and just swap the value. Okay, swap the data. In this way you can sort the linked list also. Okay, so these are the very common question, like sort the linked list, or yeah, you know that merge sort. Okay, how merge operation perform, so that merge two sorted linked list. Okay, now the data is given in the linked list, and apply the merge operation on the two sorted linked list and create a one final merge sorted linked list. So that actually required a merge operation on the linked list, or this knowledge, or maybe basic operation like just find a maximum element in the linked list, or maybe swap the first element with the last element, or maybe swap with the like kth element with the any another position element, swap these two element position. So all these type of operation you required a this traversing, this understanding very clearly. Okay, traverse operation. So and also reverse the linked list. Just linked list is given in this order, print the reverse order, or maybe just reverse the linked list. That type of question is also given in the assignments, your week 3 assignments. Reverse the linked list. In that way, what you can do, you can just traverse the linked list and just keep some pointer, like one pointer you have mentioned P1 and P2, and when you are traversing this, just connect this next field. Okay, you can maybe also use one more pointer like P3. Okay, like this connection is this. So what you can do, you can just make P2 dot next equal to this one. Okay, because P3 also contain the next, so that data will not be lost, and you can shift your pointer to the next position. So after just setting this pointer like this, just move further. So just make this as a P1, make P2 and P3. Okay, and then perform the same operation again. P2 dot next equal to P1, like this. Okay, in this way you can repeat this process until the end, and after that return the address reference of the last node, and also save the first node next field null value. So this all connection will be become reverse direction and return the like last element reference. What is the last reference that return that reference as a head. Okay, so suffix code will run on that your return head, and that list will be traversed like this. So this reverse operation, remove duplicate elements, okay, and find like a frequency of any particular element. So that type of basic operations are can be asked on the linked list. But these are the basic things you need require. First thing, understanding of the structure, what structure is given, and these basic operation. Because any operation, if you want to perform, you should know this traverse and updating the pointers, updating the reference. So that is the main thing. So I hope you have seen this type of question. We have mentioned many PYQ in the live coding session also, and I've also already mentioned that this live coding question contains the PYQ. Okay, so if you see the big three live coding questions, so that contain this type of problems. So this is big two, big three, like okay. So this, see this question. So remove duplicates from the sorted linked list. Okay. So structure is given, node class is given. So that class is totally different class. Okay. Linked list class is different. Node class is different. So you are given a class for node. That means node contain these two fields every. So the head pointer is given, and this structure is there. So this is generally called singly linked list. And now this structure is given like where the duplicate elements are there, and you need to remove the duplicate. Okay, so this problem is not just only for the live coding practice. This is PYQ questions we have added into this. Okay, so many times students ask please release the previous OPPA questions. So most of many questions actually we have added into the live coding sessions. So just practice on all linked list questions which are given in live coding session, mock, and that maybe in assignments also. Okay, or what you can think. You can also think what type of question may be asked. Okay, or right now there are lots of searching things are availability. You can search like how what type of question may be asked for the linked list. Okay, and you can just practice on that. So
Sir,
yeah.
sir, queue or stack based question won't be there.
So Q and maybe so Q is generally used. You know that in the graph algorithm BFS and DFS we use the stack. So maybe stack and queue become very easy. So if suppose if we ask to implement, that linked list based question ask. Okay, so suppose if we ask to implement the queue using linked list, okay, then some task is there. Or suppose we ask the write the implementation of stack using linked list, so that some task you have to do. Otherwise, this stack and queue can be implemented using Python list. Okay, simple. What you can do, you can take a list. Okay, suppose you are taking one list and using as a, how you can use this as a stack. So stack is just a pop and push from one side. So for push operation, you will make a push function and you will perform like L dot pop. Okay,
Append.
like this is the pop. Sorry, this is for pop, and for push, and you simply write L dot append. So this is simple 2 3 line operations you can directly implement, okay, with the help of this list. So there is
So this
not too much
won't.
task. So generally we not ask direct this just implement push and pop or using the list. Yeah, this may be asked using the linked list. Then you have to do some task. Okay, so in linked list, you maybe suppose if we are giving uh, like a linked list to you. Okay, suppose linked list is given, structure is given, head, and like some notes are given, and this structure is like this. Okay, and now we are asking that just implement a queue using this. Okay, just right using this implemented linked list. Oh, sorry, queue. So Q required a insert at first position or maybe delete it from another position, or you can insert from this position or delete from this position. So you here insert you can directly perform because you have the head pointer, you can directly connect. But to like delete, you have to traverse the list and then you have to reach at this point and you have to cut this node and like this. So some operation, traverse operation is required, some delete operation is required, some task is required for this. But main basic that operation is required, insert, delete, which I mentioned. Okay, so that are the common operation which are required for any type of questions on the linked list. Okay, so that type of question may be asked. So yeah, you should know what is the concept of stack and queue. Okay, if you know the concept, you can use that concept if that comes with this linked list. So like stack can be easily solved. Suppose this linked list is given, you can perform both operation from the head side. Okay, delete and insert. So that will be implemented easily. Yeah, so linked list based question will be easy. So as I mentioned that practice on these basic operation, insert, delete and traverse. Traverse is very important because that is required for every question, traversing. Okay, so how you can traverse from first node to last node, because if you want to suppose delete the last node, you have to traverse every operation, you have to traverse actually. If you want to reverse the list, still you have to traverse. So just practice with the traverse operation. Okay, so that type of questions like remove duplicate, reverse the linked list, insert, delete first position, last position, sort the linked list, merge the two linked list, that we have given in the assignment also. If you will solve these 4 5 questions, then you can also solve the OPP 1 question. Okay, so like this is the one, remove duplicate from sorted linked list. Okay, so that is the same type of structure you will get a first question. Only the maybe questions will be different, but the structure will be same. Like you will get a one class, you will get a one linked list, maybe type may be different, but tasks and some tasks you have to perform. Okay, but be careful about the updation of the pointers or reference after performing operation. Do not leave any operation like field empty. Okay, make sure that your all address reference should be updated properly after performing the operation. Otherwise you will get some unexpected error. Okay, so that is the one requirement. So live coding one problem, you can see remove duplicate sorted element. Live coding two problems is also very similar. You can see doubly linked list is given. This is also very similar. Doubly linked list is given, and what is the operation required? Insert at position. So some position is given, just perform insert operation on the given position. So here what is the change? Only you need to update two actually address if you are inserting in between. Okay, suppose if you are inserting between 20 and 30, so 20 next field will be updated, 30 previous field will be updated, and also the inserted node will also contain two field, next and previous, that will also be updated. So four fields should be updated, and in the normal linked list only two fields will be updated. Okay, next field. So that is the only difference. So this structure is different. So according to that, perform insert delete operation and make sure that your structure should remains the same which is given. Okay, so this question you can practice live coding 3 problem. This is, you can see, merge to sorted linked list. This is also a PYQ question. Okay, so here two linked lists are given, two head pointers are given, head 1 and head 2. Simply apply the merge operation of the merge sort algorithm. But just here you are reading the two linked list element by the two pointer. Okay, so and you will create a new list. So that is one question you have. Okay, so 3 question you can see in the live coding session we have. This is 1 second. Okay, so only these 3 are released. This private one is not released. This is just we have removed. So these are 3 questions, and also mock question we have released 2 question as well. Okay, so 1 second. Okay. So now only release part is visible. Okay, so now mock unit, you can see we have released 8 questions total. You know that 4 questions will come, but we have released double, and all these questions also are PPIQ. So that first question is simple Python logic based, no DSA algorithm involved in this. So that is like first term question. But your second question, you can see remove duplicate from the sorted linked list. I think this is the same. And third question, this is also a merge to sorted linked list. So if you solve these two, three problems and also all insert delete operation on the linked list, definitely you can solve first problem of the OPP exam. Okay, what problems I mentioned? All these basic operations, insert, delete, and traverse. After that, just like remove this duplicate and reverse the linked list, reverse, okay, and remove duplicate, and also like swapping something. Okay, so swapping the element, some specific position swapping, so reverse, remove this sorting, merging of two list. Okay, so these are very common, and maybe some additional question may be asked. So that is totally, we can not tell everything, but if you solve this type of problems, you will get enough practice to solve the OPP1 problem. Okay, so this is the list one first question you can solve. Okay, and this if you have enough practice on this type of questions, you can easily solve this question in 15 minutes maybe in the OPP exam. Okay, so that will save the time, and this is the equal weightage question, 25 marks. So we are not reducing the marks because this is easy, but this will actually the same marks, 25 marks. So I hope you have tried to solve the OPP that mock questions of the linked list. Have you done?
Yes.
Okay, so how much difficulty you feel on that linked list question? You are able to solve easily or you find difficult?
No, few are easy, but
No,
linked list.
I'm just asking for the linked list question, not every question.
Acha, okay, linked list. No, for linked list it is easy.
It is easy, no? Okay. Yeah, so as I mentioned that, just do the practice on the some 5-6 question on the linked list, and main operations or insert and delete and traversal operations. So that is the requirement. Some chat comments are there. Does grading depends on the total number of yeah, definitely. So we are following this structure from the first week. Okay, so marks is only assigned on the private test case, not the public test case. Okay, so if your some private test case has passed, you will get a partial marks for that, but not for the public. Okay, so yeah, this is the first
Hello.
question.
Hello.
uh,
Like sometimes I get like four private test cases passed and then submitted successfully. Then what about that?
So you will get a like suppose is total 5 test cases are there. The one test case has the 20% weightage. Okay, so you will get 80
Okay.
marks out of
Thank you.
100.
Okay. Thank you.
Okay, in this way. Huh. So I think the question based on login. Do we have a YouTube link for it? Yeah, this is recorded session. Okay, so this is the first thing I've talked about the linked list question. If anyone have any doubt in the linked list concept to understand, or any if you're not clear about any operations. Okay, so now comes to the second question. Okay, so second question, order may be different, maybe second question based on the graph, maybe, or on different topics, but I'm just talking about what type of yes, someone raised the hand. Yeah, Disa.
Sir, could you please explain about doubly linked list?
So doubly linked list only structures are changed. So as you know that, what is the difference between singly linked list and doubly linked list? So like structure is one head pointer is there. Okay, and that head pointer means that contain the address of only first node. After that, first node will contain the address of second node, second will contain the third node, like this. Okay, So this uh, traversing is only one side traversing. You can traverse from head to last only. Okay, you cannot traverse back. Like, okay, this is the structure of singly linked list. So each head contains the first node, but each node contains the next node. So if you are traversing like this side, you cannot reverse back from any nodes. You cannot traverse right to left, because each node contains only the next node address, not the previous node. Okay, so here only one field where that contains the address of next node, another field contains the data. In doubly linked list, only the change is maybe you have a head pointer, and each node contains three fields now. So one is data, and another is previous, and another is next. Okay, so this is the meaning. So yeah, please turn off the mic if you are not asking any question. Bhavna.
I'm sorry, sir.
Okay, no problem. Yeah, okay. Hmm. So each node has three fields. So that means if class we are creating for this node, that will contain only two fields, data and next. If we are creating the class for this doubly linked list node, so that will contain three fields. Previous, because that is actually like a reference field. Okay, this is a data field. This is next field. So here every node contains these three information: data, and previous field will contain the reference of previous node if exist. If not exist, none. Okay, so there is no previous node before the first node, so that means none value. Otherwise, next, if next is there, then address of next or reference of next. Okay, so this is the connection like this for each node. Okay, so previous will contain the reference of previous node, next will contain the reference of next node. Okay, like this way, and this is the end point. Okay, so in this this is called like as a doubly linked list, and we also maintain a tail like for this, that contain the last node reference. We can also contain the tail for this, but the purpose only for this is to just direct access to the last node. Okay, you can insert directly a new node in constant operation, but you cannot still traverse from right to left using this. But this tail node, if you have in the doubly linked list, so you can traverse all the nodes in this direction also, and from the head side this direction also. Okay, left to right or right to left, both direction you can visit the nodes. Okay, because each node contains the reference of previous node also, so that with the help of that you can traverse from both sides. And if any operation is asked on this, suppose we are inserting any node in the this between, so you have to update all the fields which are required to maintain the doubly linked list structure. So suppose if you are adding one new node in between here. Okay, so that means this next will become this. Okay, previous of this become this one, next of this become this, and previous of this will become this. So four, you can see four update is required, four reference field is required to update this, to add here. But if you want to insert any node in this singly linked list, so only one node will be add here. So this next field will be update to this node, and this next field will be update to this node, and this that will be inserted in between. So only two update is required. So in this way, so that is depends on the structure, how much update you require to maintain the structure of the linked list. Okay, but generally we also not gives doubly linked list in the exam. Okay, so just you can think about only single linked list.
Okay, sir.
Okay, yeah, meanwhile some days then Sarah. Yeah.
Yes, sir. Suppose we are given this linked list with head pointer only. So, how can we find the middlemost element in that, or the middle index?
Middle index. So first thing is there is no indexing in the linked list. Okay.
No, like the element.
Huh. So what you can do, there are alternate way. Someone else raise the hand.
Sorry.
Okay, one second. So what process you can do? Suppose if you have a head and now you have some node. Okay, so I am just making like this. Okay. and now you're identifying that which one is the middle element. Okay, so middle element, maybe suppose if the total number of elements are even, so we can I use any formula, like suppose this even like 6, then you can floor division by 2 and you will get a 3, and suppose this is odd, then still you will get like 2. Okay, so we can consider this way any middle element for odd or even. Okay, what you can do, you can apply a one traverse operation and you can traverse all the element and just read the count of elements. Okay, just make a counter, count equal to 0, apply the traverse operation from first node to last node and increment the counter for each node. So what information you will get? Total number of nodes. Okay, so 1 2 3 4 5 6 6 nodes, that counter will update. After that, get the 6 floor division by 2 and just make 3, then traverse again from the head pointer and stop at the third node. That will be your middle element. Okay,
Yeah, got it.
that you can do.
Yes.
Alternate approach you can also use. So what you can do, you can take 2 pointers, so ptr1 and ptr like ptr2. Okay, you can set this. One pointer you can always move 2 position ahead, and another
Slow and
pointer,
fast.
huh?
Slow and fast technique, right?
That techniques. So one pointer will move always two nodes ahead. Okay, so, and this another pointer will only move to the next node, and your while loop will terminate once that fast pointer will reach at the last node. Okay, so in that case, what will happen? You are at the first node, so PTR1 will be actually directly jump to this node. Okay, so PTR1 is reached, but at that time, this node PTR, this second pointer will reach at here. Okay, PTR2, and
Yeah.
then this will reach here, and this will reach at this point, and at that next time that your task is done. So because no node is there, so some constraint you have to apply here. If no node is there, then you can stop this process at this point, and this is your middle point. That technique you can use. I just make you a simple things. Just first count the total number of elements and then traverse again. Apply 2 times traverse.
Yeah, I'll try that. Yeah, thank
Okay, so
Yes.
yeah, both. Okay, so this is the first question which is discussed. Second question, I'm just talking about the graph algorithm based question. Okay, so second problem will be based on either week 4 or 5. Okay, so this is the combined, and this problem will be based on some story related. Okay, this is not just like implement a minimum spanning tree or implement a test algorithm something, but the basic idea behind of this problem will be the same. So how much algorithms we have? Main algorithm I'm talking about. Some supported algorithms are also there. So like BFS and DFS we have discussed. Okay, DFS we have discussed in the week 4, and apart from that, another algorithm. So some variants are there for BFS. Some like finding out the component, finding out the label. That some additional some variants are there, but the main algorithm is actually this BFS and DFS, and the purpose is traversing with traversal operation. Another is we have just seen topological sort. Okay, there are 2 algorithms we have, and both are very related algorithms. Simple topological sort and some longest path in that algorithm. So that algorithm main are actually in week 4, and another week 5 we have like shortest path algorithm. Okay, 3 algorithms are there. This discussed and Bellman-Ford and Floyd-Warshall. This is the purpose of is shortest path, and another is MST, minimum spanning tree, and 2 algorithms are there, Prims and Kuroska. And the purpose is minimum spanning tree. So I am just telling you the this BFS and DFS both are traversal algorithm. Okay, and just focused on these 2 algorithms, or mainly focus on this BFS algorithm. because both tasks you can do, what tasks you can do from the DFS, that you can also do with the BFS. Okay, so just try to understand this BFS concept. Okay, and what are the application of this? Just like traversing a node. Okay, so first application is just traversing all the node of the graph, all the vertex of the graph. And another application is finding the connected component. Okay, finding out the connected component. So if you have a graph and you are just looking that each vertex are connected to that graph or not, if any source vertex is given to you, so based on that some story will be given to you. Okay, that question will not be directly asked. Some story, suppose some cities are there, some that type, and that type of story you have already seen in the assignments. So some story will be given to you, and with detail will ask some details like how, which cities are not connected to this source node, this source city, like this, okay, by a road or something, like some pipelining is there, some, and which tank is not connected with this main source pipeline. So that types of some story will be given to you, but behindly total some basic application of will be there, which is based on some BFS applications. So like as I mentioned, that traversing, connected component, and one also is shortest path. Shortest path, not like this. Okay, here we calculate the shortest path based on some weights, but here using the BFS we find out the shortest path based on the total number of edge or number of vertices in the path. Okay, so that type of problem, suppose some networks are there, suppose some network are connected like this, or some friendship circles are there like Facebook friends. Okay, so if you make the graph for Facebook friends, so you will get this type of like structure. Now some question, suppose this is one friend and this is the another friend, so how much distance are there between two friends, and that distance will be calculated based on the total number of edge in the shortest one. Okay, so that may be connected like this, but from this side we are getting 3 edge, this side we are getting 2 edge. So this is the shortest distance from this like A and this B. Okay, if you will apply the BFS algorithm from A, so you will get a tree structure like this. So you will get A and then this node, and then you will reach a B. Okay, so that will provide a shortest path in the terms of minimum number of connection in between, connection in the terms of edge, or maybe connection in the terms of number of vertices. So that type of shortest path BFS is also again the same you can use. So focus on the BFS algorithm for this type of problem. Just read the problem statement and just get that what type of information is asking. So I'm not just telling you too much algorithms to remember in this week. So mainly week this BFS and topological sort. This is also important. Some if prerequisite based problems. That problem is also given in the I think mock questions. So not sure mock, but assignments also. So prerequisites are there, like some course are dependent on the another course. So how many minimum semester is required to complete all the course, this type of information. So that means some deck type of information is given to you, and like this type of structure will be given to you. Okay, okay, suppose these all vertex are course, and this is the dependency, and this is a DAG. Actually there is no cycle. So suppose you can do any number of course at any in one semester if that not have any dependency. So first this node has no dependency initially, so you can do in the first term one. So now once you will complete this dependency will remove. So these course you can do in the second term. Okay, now this dependency will be removed once you will complete this. So that course you can do in the third term T3, and then this one, okay, like T4 and T5. So this is just like a story type. Okay, so some story will be given, or some dependency will be given, and some DAG graph will be given to you. After that, this topological sort and that longest path in DAG, these two algorithms a little bit similar. You can just focus more on this, so that will be solve this problem. Okay, So in week 4, only these are the two problems. So BFS problem, see also the variants of this, because that variants is provide some additional information like shortest path or some labeling or this type of info or connectivity. Okay, so just see the some variants of this, but focus on the main concept of BFS and topological sort. Second, week 5, you have 3 algorithms for shortest path. I'll say that just remember one of the problem in these 3, which you find easy for to you remember. Okay, so if you see delta is better to you, I'll say if this is like a Bellman in the terms of implementation, Bellman Ford is very small code. Okay, compared to this Diast algorithm. So you can remember any one of the algorithm. Do not focus to remember all 3 algorithms, because the purpose is same for the all 3 algorithms. So if you are finding the shortest path, you can solve from this also, this also, this also. Just remember anyone. Same MST, just focus on one algorithm because both will perform the same task. So 2 algorithm from this week, and mainly 2 algorithm or 2-3 algorithms from this week. So BFS, topological sort, both variants. Okay, so 2, 3, 5, these 5 algorithms, just practice on that, remember, just learn this will solve definitely one problem, second problem of the OPPE exam. Okay, so I hope not, I am not saying just remember all the big 6 problem, which is the improved version of these Prims or Kruskal or this Diast algorithm. Not required, that is not required. Okay, so just because we are not asking any efficiency for graph problem, so that is a standard problem that is much efficient, but that improved version improved the efficiency, but we not tested that. So these are the main focused algorithms which you can focus. Okay, so week 5 only one shortest path, one MST is here, BFS and topological sort, that longest path in there. So one problem will be solved definitely from these algorithms. Okay, so now if you have any doubt to understand any of these algorithms, implementation or concept or anything. Who's raised the hand? Live coding question 4.2. Okay. Oh, sorry, this is the week actually. Sorry. Back and forth. Okay. Okay. Maximum number of possible route between N1 and N2. Okay, so some code is given in this. BFS path is given. Okay. You can update this following code using solution. So you can see here some additional task is there. So this type of person actually where the some additional task is required. So same type of person you can see in the given in the mock paper also, some shortest route actually we are finding out, shortest circular route. So here also some additional task is there. So in this type of person, we give the algorithms also. So here some algorithm is given like BFS list path. This algorithm is given, you can modify this. Okay, because this is given as a template. So you can modify this. So here, what is the things? So possible path you can see in this example. Let's see. So what is your doubt in any specific doubt in this problem, or you are not getting the logic completely?
So we can travel the graph using BFS or DFS, right? Here BFS is given, so we can use that approach.
Yes.
But once a path is taken, right? So BFS will show the shortest path, right? Suppose path 0, 3, 1 is taken. Now I have to remove 3 from consideration, right? Because in the
Yes.
next it should not come. So how do
Yes.
I do that? Do I change the A list itself, or is there any data structure approach to do that?
So what you can do, suppose if you are starting that approach from zero, okay, and from zero, and you are getting the shortest path, circular path,
No,
not
not the
not
path, a
circular
circular
path.
path. We want to start at a vertex and then
Okay.
find all the paths.
Source
And
is destination is also given. Okay, okay, fine. Yeah. So here, this is the source and this is the destination.
right,
Like this is the destination. Okay, and we are looking the sort path from 0 to 1. So suppose if we apply the BFS algorithm, definitely it will provide a one shortest path. So suppose it is
BFS, right?
BFS.
All right.
Okay, so suppose this is providing 0, 3, and 1. So there is but two things you can do. Either you can modify the graph. To modify the graph, you have to remove this vertex from the graph, and all links you have to also remove.
Right.
So
I was
first
facing
thing,
problem with that. All the occurrences of 3 from the
huh.
value list
So
of.
that actually I think difficult task actually removing
Mhm.
this 3, because you have to remove all the information from 4 to 3, 2 to 3, 1 to 3, all the information you have to remove from the graph.
Right.
Another thing is, what you can do, you can make another list, and where you can just put this as a like as a not consideration list. Okay, so just put this 3 in your this list and pass this list into a BFS algorithm. Okay,
Right.
and this is just like a do not consider this, which is which vertex in the inside this list do not consider. Okay, at the time of BFS traversing, when we are looking the adjacents. Okay, so
Right.
when we are looking the adjacent in this code, you can see what is the next main steps. One second first, let me, should we use new UI? One more thing, I hope you are aware of this update in new UI.
Yes, yes, very good.
This one, overview.
Yes.
This is one very important. I think you can validate your private test case status, total marks status at the same time. Question is the second tab. Huh. So in this code, you can see where we are looking the actually adjacent nodes. So for k in A, this list I, if not visited k, here just put the one more condition. What node actually we ignored? If that node is not visited, that we consider. If visited, that we not consider. But if that node is also exist in this that like this p list which we have done already, we want to ignore this, so just add this condition also.
Got it.
Okay, so like if not visited k and not in p,
All right.
okay, then this vertex will be ignored in the process, and you will get a another path without using this one.
Okay. Yeah.
Okay, so
Yeah.
that is I think the better way. Otherwise you have to update, modify the all the things.
Right. I was trying to edit the graph, so
Okay, so just modify this. Only one condition is required. Just add, I apply the and not in P.
got it. All right.
You will
Thank you.
get it, this
Sir,
information.
one more question, like what you said earlier about the algorithms. So for like, let's take week 4, for example, we have BFS, DFS here, right? And so BFS, DFS, and topological sort, it's clear. So if BFS we have covered, it's not necessarily important to do DFS also, right?
Yeah. So DFS also perform the same type of many tasks, but you can prefer BFS because that has more tasks actually. So like shortest path information that also provided, but we can't do that from DFS. Otherwise, connected component you can do from the same. Okay, by BFS or DFS both things. So
And
that
what about the weighted graphs? Like for example, there we have Dijkstra, then Bellman fold, and
So that shortest path, as I mentioned, that all three algorithms are providing the same information, finding the shortest path from any node to another node. Okay.
one is from starting from a vertex to all the vertex, like the source is
Ha.
given, like, and Floyd Warshall is like all
That
the nodes.
all pair part, yeah.
Right, right. So they are a bit different. So
So
can we specify what?
single source, and multiple path like this. These are the Diast algorithm and Bellman-Ford, and one is the all pair part. Okay. So still,
Right.
suppose what happened if you know about only the Diast algorithm, and the question is about all pair of. Okay. What you can do, you can apply this shortest path algorithm on all nodes.
Right. Yeah,
Then you
n
will get the
times
same all
right.
pair shortest path.
And negative edges. So it's better to do Bellman-Ford, right?
Bellman-Ford. So I think the code, if you see code wise, that Bellman-Ford code is, I think, very small code. So actually, we found in the previous OPP exam, if any shortest path question is asked in the exam, most of the students actually prefer this Bellman-Ford algorithms because that has small code and save the time.
Okay.
Okay, so where is the Bellman-Ford? This
I
one.
mean, Bellman-Ford also covers all the bases, right? If
So
there's a
you can
negative
see,
edge.
so after just initialization, only this three nested loop is there, and just do your task will be done. So by code wise, this is very small code. Otherwise, if you see Diast algorithm, that is very big. If you know the complete concept, that you have to, maybe if you missed something, so you will get lost. Okay. So if you can remember Bellman-Ford algorithm, that is simple three nested loop and just one condition. Okay, so just all three nested loop you can see are running the same, and this condition update, checking the distance and updating the distance
All right. Okay.
after
Thank you,
this
sir.
initialization. Okay, so just prepare any one of the algorithm,
All
and
right. Thank you, sir.
same for the MST, minimum spanning tree. So some MST type of story will be given where some road structure is given, and someone want to create a roads with the minimum cost, like minimum connections or this type of information. Some story will be given. Just figure out that what is the basic idea behind of that problem, and then apply the any one of the MST algorithm, which one you are comfortable, either Kruskal or Prims. Okay.
Thank you, sir.
So yeah, for graph algorithm, these algorithms are important. At least 4 or 5 algorithms you can just learn, and you can solve that problem. Additional task, if any additional task is asked about the problem, definitely some algorithm will be given. And also this structure, suppose if BFS related questions are there, so some queue structure will be given to you. Okay, so queue classes will be given to you. You can directly call that class, and you can, or maybe many of you would also directly use this DQ library or something. I never used, but maybe you have used.
So we can use those libraries.
You can use library. We are not restricting any library. Okay, if you have a comfort with any library, you can use.
Actually, I don't have comfort with that because first time
I'm also not
using.
comfortable with many library. I also not used any library actually.
All right. Okay.
So actually, many of the students just know about too much libraries of that to perform the task quickly. Yeah, that is also good. Actually, you can save the time if any timed constraint exam. So that is, we are not saying that do not use any library. If you know, definitely use.
All right. Thank you, sir.
Okay. So this is the second question. So just prepare all these things. Okay. And if we discuss about the mock question, so as you just quickly recap mock practice problem. Okay. So fourth problem, I think. Oh, this is just little bit okay. Distinct number. Peak unimodal. Okay.
So it's week. It's
Huh.
related to week 2.
That I'll discuss that also. You can see this is your shortest circular route. I hope you got the idea of this, how to solve this. Can anyone of you mention what approach? Definitely, we will discuss all this problem on Friday. Okay, so don't worry about that. We will discuss in detail code. But anyone of you have solved this? This is also very similar what we just discussed in the week 4, that live coding. Some update is required in the graph, then perform the same thing again and again. and finding out the minimum among all. Okay, no problem. Just try 2 days more. Okay, then we'll discuss on the Friday. So mock 5 6. Oh, so only one graph problem is given in this. Okay. So one question definitely will on graph algorithm. So practice on this. Next, come to on one one problem actually. Okay, so these two problems are confirmed with these topics. One is mentioned as DP, that is definitely will come, and one is will come from different topics. I think that is binary search, maybe. Okay, maybe binary search tree, maybe greedy. Okay, so we cannot tell you the exact, that may be changed. Binary search problem, if question is asking about like some solution in log n time, okay, log n time, so that you can think about the binary search type of concept, and you can not directly binary search related. Okay, so we will not ask like you have a increasing order, just apply the binary search, some version of that. And that version we have also discussed some this mock, you can see peak unimodal, finding the peak element, like your list is in increasing and decreasing, this order is given, and you need to find this one. Okay, so that is the one possible problem. And this binary search techniques can be applied if you know the pattern of the elements, how the elements are actually arranged, not only in increasing order, all maybe another order may be possible, but how you can discard half of the element based on the some pattern knowledge which you have already. Okay, so here the pattern is like this. Initially all elements are increasing, at one point all elements are now decreasing. So that means from this point right side all elements are like decreasing order, and this side are like increasing order. Okay, so based on this information, so suppose if you are jumping at this side, so in this side the order will be like m1. Suppose this m1 element, that will be smaller than m2, then that will be smaller than m3. Okay, so that means if you are getting this order, that means your peak element, I have created wrong. Okay, decreasing, oh sorry, so that is the order. Decreasing. Okay, so that means peak will become at this side. So you can discard this part completely and just see this side only. So that means if question is about asking about the log n solution, definitely you have to discard half of the problem at each step, then you can achieve the log n solution. Okay, so that is the way only. So but problem may be different types. So this is the one problem. Another problem we have seen, like if your sorted list is rotated, so like 1 2 3 4 5 6 7, this order is there sorted, but if suppose if we have rotated this 2 3 times, so after rotating this element will come here, so this will become like this 5 6 7 1 2 3 after rotating 4. Okay, so now some rotated list is there, but still this has some pattern. So at till point this is now increasing, but after that you will get a smallest element and then increasing. So based on that, you can also figure out some way to discard half of the element. So that problem we have also, I think, covered in any of the assignments. So that is the one version. Some version maybe if your list contain the duplicate elements, so like 1 1 1 2 2 2 3 3 3, like, but it's still sorted. Okay, 4 4 4 5 5 5. So here also just asking like number of occurrence of any element. Suppose we are asking how many times 4 is coming in this. Okay, or maybe the first index of 4, or maybe last index of 4. So this type of information, I think this question is given in the week 8 assignments, number of occurrence. So in that type of case you can think about some binary search type of concept, because here also pattern is there. Okay, so suppose if you're looking for the 4 and you are jumping at the 3, so you can discard this part completely because order is sorted, but duplicacy is there but order is sorted. So one, this type of problem is possible. And one problem like suppose if you are given all element 1 2 3 4 5 6, all distinct element, maybe basically, okay, 6, 7, 8, but in between you missed one element like 9. Okay, 9 you missed, and that is 10, 11, 12, 13, 14, 15, like this. Okay, order is there till. Okay, now you have this list, and we are asking find out the missing element in the log n time. Still you can apply the binary search type of concept here, because here if indexing is there, so because we are continuously saying our all elements are from 1 to n continuously without skipping any element, but at any point one element is missed. So that we can figure out based on this indexing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. So if you are jumping at any point, you can just make sure that if 1 is coming at 0 index, so 9, this 10 should be come at 9 index. Okay, but it is coming at the 8 index. So that means some element is missing on this side, not this side, because here index difference is there. So you can discard this part and see the missing element on this side. Okay, same things if all elements are in this given and any one of the element is duplicate multiple time. So this is the different version of this problem. So like 1, 2, 3, 4, 5, 6, 7, 8, and 9, like this is repeated, and 10, 11, 12. And we are finding out which element is repeated multiple time. Okay, and say any single element is there. So same index, you can just simply compare with the index, and this should be like 8 index, 9, 10, and 11. Okay, so this 10 should be come at the 9 index, but it is coming at the 11. So you can discard this part and see this side. So this type of some logic you can figure out that if question is about the binary search. Okay, so how you can discard half of the input at every iteration or every step. Also for this type of solution, do not use slicing. Okay, we have mentioned this many times, also mentioned in our notes, GitHub notes. Do not use slicing like this, one dot, okay, like this, like, and this -1. Do not use this slicing in any point of this binary search concept. Maybe professor have discussed binary search algorithm using this, but the idea actually is not, professor have discussed the concept, okay, and use this, but internally this operation is actually in Python takes order of n time. Because of that it may fail to achieve the log n complexity, because what is the way of this slicing means is we are copying all the element in a new list. Okay, so that copy operation, one by one all element will be copied into a new place. So that is order of n operation. So use only the iterative version or recursive version without slicing of this binary search. Okay, so log n, this is one possible binary search question. So I tell you many type of questions. Simple binary search, maybe like rotated list, maybe that multiple repetitions are there, so number of occurrence, that type of question. This question we have asked in this, these two questions I have asked in PYQ also. Okay, so this missing element or duplicate element in a this type of list. So you can practice on these 4-5 problems on the binary search related. Okay, and so another is binary search tree. So binary search tree is not just much difficult type of questions what you should know. So that is also very similar to linked list type of questions. Okay, so link, you know that there is a root node. Okay, in the some tree will be given to you in the question, and you know the structure of BST. Each node, like this is suppose 20, this is 10, this is 40, and this is 30, and this 50. This is 5, this is 15. Okay, so binary search tree may be given to you, root reference you will be given to you. So what type of question may be asked for this? Maybe insert operation. Okay, so insert operation, you should know how to traverse the list. So simple that how we solve that binary search insertion in manually on the paper. Suppose we want to add like 60 node. So we will start comparison from 20. If this 60 is greater than 20, we will move to the right side. Okay, of right child of this. We will reach that here. Again, we will compare. We will move right. Again, we will compare. It is greater. We will see if the right child is null. Okay, because each node contains the three field here. Okay, left field, right field, and data. So that's 50. So if right child is null means there is no node. So create a new node and add this reference and save null here. Okay, so that 60 will be add here. So this is the insert operation. Okay, so only just focus on the insert operation. Delete operation we don't ask because some multiple task is required for the delete. Finding the PDSA or success something. So only insert operation or searching operation, because in insert operation searching operation is required by default. So search operation is the same things. If you are searching like 30, you have to start from here. 30 is greater than 20, move right. 30 is smaller than 40, move left. So move left means, suppose if you are taking any point at temp equal to root. So you are comparing 30 is greater than equal to temp dot data. Yes. So temp equal to temp dot right. This operation. Okay. Just move to the right child. Again here come temp equal to current. So current node is this. So again compare the data. Then based on that move to the left or right side. And if you find out the searching element, you can return to yes, this element is exist or not. This step. Okay. So main searching operation, just focus how the searching happens on the binary search tree. Okay, if you know the searching, you can also easily do insertion. Another operation is like finding the minimum and finding the maximum. Okay, these are very common operations. So if you are finding the minimum operation in this tree, so always traverse from maximum possible left side. Okay, so left to left, where you will find out the null. So that element will be the smallest. If you are finding the maximum, move from right, then right until you will reach at the null. That will be the maximum. So this finding minimum, maximum, this operation is important. And another operation is traversal. So that traversal you can, I think, recall in order, and that is very small algorithm, recursive algorithm, in order traversal. And if you will learn one algorithm, you can easily convert that into a pre-order or in post-order also. So you know that suppose if we ask that what is the sorted order of this, just print this binary tree into the sorted order. So just apply the in-order traversal and print the nodes. You will get a sorted order. And if you will see what only 3-line implementation is there. So for this recursive implementation. So binary search operation, only these operations are required. Binary search, yeah, this one. So you can see find. So this find operation is there. So this is just like a searching operation, but traversing, insert, Maxwell, return. Okay, traversing is not there. Make empty mixing. Okay. Traversing. Right. The traversing operation is not there, but I think this is there in the AVL tree. So here you can see this in order traversal. This is written like some different way. Okay, so but otherwise this can be written only 3 steps. So in order traversal, this is the base condition. Else part, just move to the left child and recursively call the same algorithm. Second step, just visit the node, current node, and last step is just move to the right node. So easy algorithm, easy steps you can write like this. Okay. So suppose if you are applying like in order, and this is like a node, okay, current node. But initially, suppose if you are passing root. So if temp does not equal to none, okay, then you can write these 3 steps. So apply the in order algorithm on the temp dot okay dot right. Sorry, left. Okay, and like traverse, or we can write simple print temp.data. This is the second step. And in order, this is the recursive call again on temp.write. So the same algorithm you can like in these four steps. Okay, in order algorithm. If you want to make this as a pre-order algorithm, so what step will be changed? Only change this pre-order, and move these steps to first position. Okay, then it will become a pre-order. If you want to make this as a post order, so change the name post order and just move this print statement at the last. There is nothing changed. So this is traversing algorithm. At least remember this in order traversal. Okay. So in order traversal, you can traverse all the nodes and you can perform the operation on the nodes during the traversing, or maybe count the node, or like this you can do. So just remember this, at least traversing algorithm, basic searching operation, and this finding max, minimum, all these are the searching actually. So this is based on the binary search tree question. And greedy algorithm, just remember what algorithm is discussed in the lecture. There's interval scheduling, minimum lateness, or I think that's OPPE tree. OPPE tree is also not much important, but just remember only interval scheduling and this minimum lateness. These two, that is enough. The greedy algorithm. Okay, so one problem based on these topic BES and BST and greedy. Okay, so that just practice on these topics. Binary search based problem, binary search tree basic operations, and this greedy algorithm, what are discussed in the lecture. Okay.
So heaps will not come.
Heap is also not important, but heap is also not much difficult algorithm. But yeah, you can leave that. That is not important.
Okay, so BST and greedy only. No, and AVL
BST operations, binary search related problem, and greedy algorithms. Also understand that what is the concept we basically used in the greedy algorithms. Okay,
right.
so course problem are there, but you can also explore some more problems to practice.
And AVL trees are there?
Not there. Okay, so that all big problem like AVL tree and this find pair shortest point. Okay, pair that type of math multiplications or this type of that are big algorithms are not there. Okay, not required. And one last fourth problem actually based will be DP. So DP, definitely we cannot say that problem directly based on the course problems, but if you have understanding of how to solve DP problem, then you can solve this DP problem, and the problems will be easy problem only based on 1D type of stories, not the 2D. Like 2D array, you have seen the longest common subsequence, longest common that substrings, where we are maintaining 2D structure to store the data. But the problems we will give in the OPPE exam generally based on the where you can store the data in only one dimension to solve. Yeah, here some practice is required definitely. There's no direct formula for DP problem. You should have understanding of the DP problem, how to solve, and also before understanding the DP problem, you can also focus how the problem this DP type of problem can be solved using recursive approach. So if you understand the recursive way to solve that problem, you can also solve during using the recursive way. Okay, because efficiency still we will not check for DP problem in the OPPE exam. So you can apply your recursive thought process. If you are not reaching to the DP concept to solve, you can think about the recursive approach. Recursive is just like to find out the all possible way to solve. Okay. So some problem, what problem we have covered in the course, definitely practice on that and understand that how actually you are using the DP approach, how you are starting from the base problem, smaller problem, and reaching to the main problem, and solve all the live coding problems solve these I think two problems given in the mock question also. Definitely OPP problems will be similar to that or maybe easy to that. Okay, so DP definitely we cannot make and give you any formula for this. Okay, so that is totally depends on your practice, where you have to come to the solution. Like you can use recursive approach also, but you can also use the DP approach if you restate the way. Yeah, Sarah.
Sir, could you just like go to that PP second last question in mock? I just wanted to know the parameters in that question.
Okay.
Yes, 7th.
This is the okay. You know what is mentioned in the top Indian National Olympiad in Informatics. Okay, so this is just like a competition problem, and this problem is given in the first of the term in PDSA OPP exam. Okay, and
Like I'm getting the logic. Like we'll go horizontally first and then vertically, and then we'll get the maximum between the vertical and horizontal. But like, what will be the function and the its parameters? Here they have not defined or mentioned any such thing.
so here what you have to think about. So our what is our task actually to find out the score, which is actually I think minimum no or maximum we are asking maximum score. Maxima we are scoring. So how you can solve this smartly actually? Okay, so let me just make you this style. Let me copy that.
I have a doubt in this.
Mhm.
I got a code, but I'm not able to find what they are asking. The function name is not given. When I submit, it doesn't read anything.
Exactly. That's what my problem is.
So here you need to write a complete code.
Yeah, I have it. I mean, it is working in my portal, but not in the portal, but it works in offline. How do I?
Okay. So you can see what type of input is there in the test case. So we are just passing the 4 values in the both list. Okay, so that data you can maintain in the list,
Okay.
like 8623 and 9712. Two lists you can maintain like A and B.
You want me to read the input and then
Yes, everything.
without any function being normally most all the other questions are always
yeah. So here this is given an input format and output format. So that here you need to read the complete input also and print the output. No function is there. Okay, for this question, just read the input also. Yeah, so this is actually first term. After that, we are just following the same type of structure. We are generally asked to write a function.
But these questions are all more like for solving a puzzle.
Yeah, as I mentioned that no, this is the one competitive that actually Professor Madhavan sir actually maintained this.
I understand. These are all things for the Olympiad, outside, off the line, it's okay.
Yes.
But not in the PDSA where we are probably come with an algorithms and then.
So this is DP based. So dynamic programming approach, we can hear some hint is also given.
Those fine. We can divide the problem into 3, 4, whatever it is. But then to approach this as it is, whether to put it as this is a puzzle.
Yeah.
Puzzle.
Interesting as well as time consuming.
This kind of problem in OPPE, and where then we look at the problem and spend 2 hours on solving.
No, as I mentioned that, so this is the first term where we give this type of problem, hard problem initially in the terms, and many of the students have solved also. But after that, we saw that that the students are not able to solve this level of problem during 2 hours. So we have also reduced the levels of the problems.
Let's see
in this. Okay, and we added this into a mock. So now to solve this, actually, if I one second.
No, actually, sir. Like if others want, you can do, but I got the logic. I was just confused with the parameters. And I wanted to.
Parameter means what you are asking. So we
No, no, that's
actually.
input. I was not aware that.
Okay, input
We
part,
have.
na?
Yeah.
Okay, so that first value is just a how many elements are there actually in this
Yeah, the
actually this is
call
the list, na?
columns. Yeah.
So you can see 4 elements are there in one list. So that value is the first input. After that, these are you can consider as two list A and B. Just store that data into this. Okay, so this is just like a total number of element in each list because we will always give that equal number of element in the both list. So read this value and just save the in this list this data into two list and then perform your task. Okay.
Yes, it's
So
clear.
this is the input. Here you need to write a totally fresh code without you. There is no code is given in this. The
Yeah,
suffix or prefix.
yeah, that's what the that's what I was facing. My code
Yeah.
was passing, but no output was there.
Output is not coming correctly.
Because input was not there. No, I did not like.
Okay, got it. Yeah, so this is the way. We will also discuss this in detail in the that session, Friday session. I am just giving the hint how we can use the DP approach for this. So we can just like create a one result that list. Okay, so where we will store our result. So where so how many values are there? So 0, 1, 2, 3. Okay. So three total four that index are there. Okay, so we will maintain the result for each index, and we will also create a one additional index. Okay, so like 0, 1, 2, 3, 4. Okay, so like this, and we are assuming that this is one additional where nothing is there. Actually, 0, 0 we are assuming. Okay, and this is just a fourth index. Main problem is 0 to third index. This is the main problem. Now start like we will start from the smaller sub problem. So suppose we have only this fourth index and we have only this problem 0, 0. So how many vertical or how many horizontal we can make? And I think the formula to finding out the maximum score is the difference that is like a score. The telling one is 12, 9 is okay. How we are getting this?
Absolute difference between two adjacent tiles.
Okay, 1 second. 12. So 9 minus 8 and 6 minus 2, 7 minus 1. Okay. Yeah, so every tiles we are just finding out the absolute difference and we are adding all this, and that should be the maximum. Okay, so that we are doing. So here, suppose if we have only this problem as input, so what will be the solution for this? Because we can make only this vertical tile.
Your audio is not good.
For this sub problem, this is the one smallest problem we have just making as a base case, and this is only the way you can make this as a vertical. Hello? Oh, audio is not.
No, it's fine.
Yeah, what is the issue?
Like for me, it's fine. Your voice is coming.
Coming now? Okay.
Yes, sir.
Okay, so here you can see we are starting with this sub problem, and what will be the solution for this? So we will calculate the absolute difference of these two values, and this solution we will store here at this point 0. Okay, so after that we will increase the size of sub problem. So that is like a now we will increase the size. Okay, so this is like a fourth index, and this is 30, and we will add 3 and 2. Now this is the way 0, 0. Now what will be the solution? Because we have the solution for this tile, vertical tile. Okay, this vertical tile solution we have already saved here. Now what are the way? So at every steps, what we will look for, we will check the horizontal. Okay, so every time we will just check the horizontal and the vertical. What is the vertical? Okay, so vertical we will only look for this which we are adding new, because previous vertical we have already solved that, and that solution we will directly read, but horizontally we will calculate. Okay, so horizontally we will so that means we will make two like this first horizontal solution if we are considering this horizontal tile, and another is vertical tile if we are considering that vertical tile. So what are the two possible solutions for this problem? So if horizontally we are taking, so 3 this 3 minus 0, that is 3, and plus 2 minus 0, 2, so we are getting 5, And if you're taking vertical, so only this we will calculate. So 3 minus 2, 1, and we have already calculated previous one. We will directly read from here. Okay, so that is plus 0. So among these, which one is the maximum? So that we will select. Okay, so this is the 5. So till now, what is the solution for this problem is now 5 in this way. Okay, so now we have the solution till this part. Now we will increment one more. Okay, we will consider one more. So now 0, 0 is there. Now 3 and 2 is there. Now we will add one more, 6 and 7. This. Okay. So now we will focus for this because we have already calculated the maximum solution for this part. Okay, that is 5. Now, if we consider this as a max, this as a vertical, so vertical will be only 7 minus 6. Okay, and plus what is the maximum solution till that point? Okay.
So why are you taking 6 and 7? What happened to 2 and 1?
That we have already solved. No, 3 and 2 we have already solved. We are just considering this as a vertical, and we have already solved this part, and we have already stored that result for that problem. So maximum solution for this this part. Okay, and this new vertical tile we are making. Okay, so this 7 minus 6 we are getting 1, plus what is the maximum solution for this previous part? Okay, that is 5. Okay, that is 6. And if we make this as a horizontal tile, okay, like this, 6 and 3 and 7 2, so that will become a solution like 6 minus 3 and plus 7 minus 2. And what is the solution for this part? Okay, that is 0. So plus 0. So we will calculate like this. Okay, so 6 minus 3, 3 plus 5 plus 0, and that is 8. And these two possibility, what is the maximum? That is 8. Okay, that we will store here. Okay, so now our problem is solved. This level, this problem is solved, and we have the maximum solution. This 8. Now we will add one more. 6. Oh, we missed. Oh, sorry, we missed that.
That's what I was telling you.
Oh, okay, sorry. Yeah. So let's correctly do this. So 3, 2, 0, 0, and that was actually
should have taken 2 and 1.
1. Yeah, 2 and 1. Yeah, sorry. Okay. So previous solution we have already done here. So this time we will see for this 2 minus 1 this part, and what is the solution till this last 3 values. That was 5 actually. So that will become total 6. Okay, so this is like if we are considering vertical tile, this one. And if we are making this as a horizontal, then we will calculate the solution like this 3 minus 2 and plus 2 minus 1 and plus 0. Okay, so we have the solution for this already saved. So 1 plus 1 plus 0, that is 2. So what is the maximum among these two? 6 and 2, 6. Okay, so that we will store here. So this is 6 here. Okay, now we have the solution this part, and now we will add one more in this. So now we will become 4. Okay, so that is 0 0 and 3 2 and 2 1, and that was the 6 7. Okay, 6 7. Okay, so we have the solution till this part. Maximum solution is 6. Okay, this one. If we are making this as a vertical, so what is the maximum solution of remaining part? That we will directly add. So 7 minus 6 plus 6. So that is 1 plus 6, 7. And if we are considering this tile as with this one, like this, and so solution we have already for this part. Okay, so 6 minus 2 plus 7 minus 1 plus what is the solution till this point? That was, I think, 5. Okay, 5. Okay, so 6 minus 2, 4 plus 6 plus 5, that is actually 15. So maximum among 7 and 15 is 15. So that will be update here. This point 15. Now we will add the last one. So final one. So 0 0 and 3 2 and 2 1 6 7, and that is last one is the 9 8 9. Sorry, 8 9. Okay. So same thing if we are considering this as a vertical, so vertical solution will be 9 minus 8 and plus 15. Previous solution was 15. And horizontally, that was just like this tiles. So 8 minus 6 plus 9 minus 7 plus what is the solution at this part? Okay, that was, I think, this 6. Okay, so 2 plus 2 plus 6, that is 10. So 15 and 10, which one is the maximum? 15. So that is the 15 here. Okay, so we got this as the final solution. So that means we can make the tile in any way. So we will get this maximum solution 50 for this. Okay, in any way, if you will select any possible way of the tile selection, you will get a maximum on this only. You will not get maximum more than this.
It doesn't match with the answers given.
So maybe some calculation mistake. So what is the answer for this?
Let me tell you, 12.
Okay, 1 second.
And my code also comes to the 12. Of course, I didn't follow this method. I did a brute force.
No, so if answer is 12, maybe our some calculation mistake will be there definitely.
Yeah, I just want to know whether the logic that we followed, are we to maintain two tables for a horizontal sum and vertical sum?
Logic is correct, but let me just quickly check where we done the mistake. So if we are making this as a tile, so 3.
I got stuck in the last case 3. Case 3, it has got some 45 values and it's too long time to do the brute force. So that's why I got stuck.
Okay. No, I'm just verifying this answer again.
Let's check. I like this. I love this, but this is more like a puzzle. I never played.
So 3 minus 2 is 1 and 1 plus 0. So I think this is the mistake. If you are making this vertical, 1 and
we are tracking only this optimum one. We are not looking at whether if it is the non-optimum, we are not keep tracking.
Oh, okay. Yeah, we give the mistake because we also consider this as a this vertical tiles, and that is not the part actually. Okay.
That's why I wanted to have a systematic way of approaching.
Yeah, so we will not include this horizontally because that is not the part of the problem. So we consider this. Actually, we have added this to make our code actually synchronized, because at any point we will follow some specific code to solve this. Because what is happening? Suppose if we are looking for this index 2. So at that time, we are just checking this 2 and 1 vertically. And after that, we are checking 2 and 3 and 1 and 2. And what is the solution of previous one? That we are following with the every steps. So if
what you're saying is, no, we have to analyze the 4 elements on hand. The rest we take it as a frozen.
Yeah, correct. So this steps we have done mistakes. So this 3 minus 0, 2 minus 0 I have done, that we will not be considered. Only at that first step, we will only consider this 3 minus 2 plus 0. So that is 1 only.
That is all right. No, you're coming from left to right, I mean right to left, and then I gone from left to right. It doesn't matter. The same logic.
Yeah.
Take 4 elements at a time and see the permutation which suits best, and then freeze it. Keep adding the next 2.
Yeah. So I think that will become correct. So that was our mistake. So I think
that's okay.
So after that, we will follow the same concept. Okay. So that's only this is
basically the permutations we are going to do only for 4 numbers at a time to find which combination, and then keep moving the slide it.
Yeah, so that is also possible if you are just looking for the all possible permutations.
No, that's what you are doing here, right? You're considering 4 numbers at a time. Initially, you took 2 and then considered 2 as a 0, which anyway is going to be thrown.
But here we are using the DP approach, and we are reusing the solution. We are not solving again the same part.
We are not. Once you freeze it, then obviously that is not a problem. You keep solving 4 numbers at a time incrementally.
Yeah. So that is the DP way actually. Otherwise, if you can figure out the all possible way, that is the different way actually. That is just like
we add 2 at a time. 2 at a time and consider the 4 combinations. What best we can do.
Yes.
Keep going.
And previous solution we are reusing, because of that we are considering
Correct.
4 at a time.
So then you need to maintain both.
Yeah, correct.
Both the sum. Here you have taken only one sum, and that is one of the possible reasons why probably you've taken only the maximum.
Yes.
The sub maximum also we are going to choose, because if I change the ordering, then it will become that.
Correct. So yeah, this is one actually competitive problems.
It's it's not for PDSA.
Yeah, manually it's
Nothing to
easy
do with
to
the computers.
Manually, for a small example, this is easy. Suppose if
When
this
we
is
start coding, it gets very, very confusing, like initializations and all that
for
variables.
this example, maybe you can figure out all possible like combination of tiles, but bigger example you cannot do manually also.
Yeah.
Okay, so yeah, this is some like competitive problem. So now this time we gives only very basic DP problem, not that level of problem. Okay, so that is just, and we also not release some competitive problem in live coding actually this time, because last time we released, but most of the students actually not solved that. So because of that we not released. Otherwise, one question, if I'm not sure, in week 3, sorry, week 4, I think, in practice assignment, that is also a challenging question. This was given or not? I think this one, maze solver. I'm not sure how many of you have tried this and you have solved this. And we have also mentioned that challenging problem and optional.
Where is it? Week 4, is it?
Week 4 PPA 3.
Okay. Maybe tomorrow morning I'll try.
Yeah. Okay. So that's the things for OPP. So as I mentioned that OPP, this programming exam preparation cannot be done in maybe 1 or 2 days. Definitely, this is the previous experience what you have done in last 2-3 months. That will definitely useful for you. You can recap quickly these important topics or these algorithms, and then you can do. Okay, so that's it from my side. If you have any question, you can ask. Like coding question 4.2, someone mentioned this. To this.
A small doubt. I forgot that OPPE. Do you allow this portal where we can that? What is it? Collab?
No.
Collab is not allowed?
No. Only portal.
I mean, how do I check this?
Yeah. So one thing we are giving, I think. So some like additional like Python tutor or some additional things we are giving.
Okay, Python tutor, that's good enough. That PyDot, right? PyDot.
Yes. So in the question statement itself, maybe at the bottom, some links will be there, like Python tutor or some, I think 2-3 links will be there.
Okay.
So that you can open and you can just like debug. Or
I don't have to memorize the syntax, whether it is a stripe or a strip or whatever it is, right?
So that I think for PDSA we are giving.
Okay, that's good enough.
But additional tab out of this portal, I think that is not allowed. Maybe it's Colab or something.
Which one is?
Means you cannot open additional tab outside of this portal. That is on any editor you cannot open.
No, the Python tutor is the only one I want. I just want to check that for indenting is right or whatever nonsense.
So I think that links are there.
Those common things are required.
Okay, that we have already
discussed. This question was discussed.
Discussed. I think I just looked the chat actually, so this one mentioned at the last. Okay, so we have already covered. So Friday we will discuss all these 8 problems, mock problems in the details. And I hope you are also joining this TA session that is divided into the topic wise actually. so that he's covering some problems in for the each topic. That sessions are also recorded. If you have not joined, please watch.
Thank you. Good night.
Thank you.
Thank you, sir.
Thank you, sir.
Okay. Good night.